Section 13.1.8, we want to fill in the ANOVA table. So here we have the source of variation. We have treatment, we have error, and then there's the total. The sum of the squares for the treatment is 565. The sum of the squares for the error is 3,560. The degrees of freedom for treatment is 5. The degrees of freedom for error is 32. And we want to be able to find the mean squares and the F test statistic, and also the total. Now, using the formulas from the general Anova Summary table displayed below, where K is the number of populations and N is the total sample size. So MST is going to equal SST over K minus 1. The F test statistic is MST divided by MSE. And then MSE is going to equal the SSE divided by N minus K. The sum of the squares is taking the total of those two, which is the treatment plus the error. And the degrees of freedom is going to be the value of N minus 1. So the first thing for number 1 is we want to start by finding the total sum of the squares and the total degrees of freedom. So if we add 565 plus 3,560, then we're going to get the following value. We get 4,125. And then the degrees of freedom, we're going to add together to get 32 plus 5, which is equal to 37. And therefore, there are our degrees of freedom. Next, number 2, we want to find the mean, which is the square due to treatment. So the mean square due to treatment is MST. Now remember that MST is going to equal SST over K minus 1. So what does SST represent in our problem? Well, SST is 565. And then we're going to divide it by the degrees of freedom in that row, which is 5. So we have 565 divided by 5, and therefore we get the value of 113 for the mean square due to treatment. Okay, next what we're going to do is we want to find the mean square due to error, which is MSE. So that's going to equal SSE over N minus K. Now, the value of SSE represents the value that's due to error, which is 3,560. And then we're going to divide that by the total of the degrees of freedom for that row, which is 32. So we end up getting 3,560 divided by 32 gives us a mean square due to error of 111.25. Okay, now the last part for number 4, the F test statistic is the ratio of the mean square due to treatment to the mean square due to error. So that means we're going to take the value of MST and then we're going to divide it by the value of MSE. So we can see here that over to the left, the value of MST is 113, and then the value of MSE is 111.25, and if we divide those two values, then we get the F test statistic of 1.1016. And therefore, this is going to give us our total summary. So we can see that for the treatment, the mean squares, we got 113, which is the mean squares treatment. And we saw that the F test statistic was 1.016. And then in the next row, we had the mean squares due to error was 111.25.